Right, so moving on, question number 20. So before getting to question number 20, I have put here question number 20 of 2014, which we discussed earlier in last week. So what is the difference between these two? This is N2O4, this is N2O5, where additional oxygen is present here. So for N2O4, if you can remember, for N2O4, I gave you all these resonance structures. And for N2O4, in fact, what we did, after putting all these electrons here and the chargers, we were able to see that I can draw like this. So nitrogen 8 is complete, oxygen 8 all complete. There is a negative charge here and there is a positive charge here. And this was one of the structures, and this is 2 oxygen here. I can change this one of oxygen to this one. For an example, I can put like this, the resonance, and make this happen like this. So then in the other structure, there will be double bond from this oxygen and negative charge from this oxygen. Okay, and I can do the same for the other structure like this one, and this. So this would be the first structure, this would be the second structure, and this resonance would give another structure. And the fourth one will be these 2 oxygens giving and these 2 breaking. So there will be another one. I drew these 4 structures last time, so we discussed about this. So it has 4 structures. But what is the difference between N2O4 and N2O5? So in the middle, there is another oxygen. Here, there will be 2 another lone pairs that is coming. Okay. So in fact, you can imagine with these 2 oxygens, without this central oxygen, they had 4. So again, here there is a similar case with this terminal 2 oxygens. There will be 4. Okay. Now, the other resonance structures will be determined by this oxygen, because one of these oxygen can give this lone pair to this at one time. So as this and this can contribute, and another can give by this oxygen. So there's this oxygen and this oxygen can contribute another time. Okay. So basically, when you have this oxygen giving another contribution here 2 times and another contribution 2 times with this lone pair of oxygen to this nitrogen as well as to this nitrogen. So you will have another 4 resonance structures using this oxygen. Okay. And additionally, there can be another resonance structure where this oxygen can give 2 electrons to these 2 nitrogens. So basically, there will be 9 resonance structures that is you can form. Okay. So if I want to show that, just an explanation. So here we have this one. This is our skeleton. So there can be this one and this one minus minus. And there is plus plus. And there can be this oxygen same. But only difference is this is changed, right? So this can form like this. And oxygen NO minus. This is another one. So this is terminal. This is also terminal. So this can be present like this as well. Oxygen, oxygen minus minus. This is another one. Okay. And here similarly, I can think about this structure when comparing these two. Here I kept this one constant and change this one. In the same way, I can keep this one constant and change this one. For an example, here there will be O2. O minus. Okay. So these are the 4 resonance structures that can be taken from these terminal oxygens. Okay. Now, when I change this in the middle oxygens, so if you ask me the question from where these lone electrons come, it is from the normal method. You count these 2 nitrogen 10, 5 oxygens 1, 2, 3, 4. Yeah, 5 oxygens 30. So you can divide, and then you can reduce the number of electron pairs from the skeleton. Then you can put the lone electrons, and you can see. So there will be 2 here. And the other thing is that you can do here 2 electrons can be given like this. So it will be like this. There will be a positive charge here now, nitrogen, O minus, O minus. This also can be given like this. And this O minus could be either from this one or either from this one. So basically there will be one that is coming from this one and one structure coming from this one. So there can be 2. Okay. Here also another 2. And you can imagine like you have 2 oxygens on the same direction and 2 opposite direction, like one up and one down. I have not drawn like one up and one down. I have just drawn like the flat structure. And in fact, you could imagine a compound like this also. But this would be highly unstable. Okay. Your overall charge is still 0. So anyway, the idea is you should have drawn these structures when you learn your primary general chemistry things, Lewis structure, atomic structures and Lewis structures, because these are very simple things. And I used to say to the students, when you have these questions, like when you come up with from 2011 to 2020, get all the structures that is possible to draw the resonance, even unrelated. For an example, there were like SSF2. So try to draw a resonance structure for that, SSF2, if possible. Why? Because these are the common structures that we see, and there will be the same structure that they will give to draw the resonance, because they can use some other undefined structures. But in general, when you practice these, automatically it will be easy for you. Okay. So think about the relation. This is also 20. This is also 20. Just oxygen is 10. N2O4 is N2O5 now. Little bit oxidized.